Diagram number 3 has two straight lines, PLN, MLK. There's a big angle here, small angle here, big angle there, small angle there. They have a relationship based on their position, which I'll explain in a minute. Let's start with the measurements. I'll line the protractor on line PLN and put the base line on very carefully. Sweet Moses. Okay. Now, the measure of angle NLM in here, it's not lined up the best, but it's 10, 20, 30, it's at 35 degrees. If I extend that line, it would be at 35 degrees. On the other side, angle PLM here starts at 0, up, beyond the 90, 110, 120, 130, 145. And the same thing would, let's just prove that. If I flip it around and measure the two angles on this side, you're going to see a pattern. Okay, so the angle PLK from here, 10, 20, 30, oh look at that, 35. Angle NLK, 10, 20, 30 on the outside, 90, 145. Let's take this off and write down what we saw. So, one second here. This angle was 145. This angle was 35. This angle was 35. And this angle was 145. There's a relationship. And I want you to have in your head the terminology, what we call vertically opposite angles. The angles that are across from each other are always equal. Notice they're big and big. And the angles that are across from each other on the other side, small and small, they're equal as well. And they're called vertically opposite angles. Notice 35 and 145 are adjacent, side by side. Notice that they also add to give you 180, which you would expect given that line straight and cut into two pieces. These two angles add to 180. They are called supplementary angles. These two angles add to 180, supplementary angles. So do these. Together, all four angles add to give you 360, which would be a complete circle. In your mind, have the slang expression of scissors. In a scissor pattern, the opposite angles are always equal. Now, in the next one, number 4, we have some lines. You should see a pattern maybe just by looking at it visually. Hopefully your eyes say something. Hopefully you can make a guess about angle H and angle G and F. This time there are no letters out on the sides, just letters in the corners. This protractor is backwards. I'll lay it down and we'll prove probably what you expect. And that is that the measure of angle H is a 90. Okay, straight, it's called a right angle, 90 degrees. On the other side, the measure of angle F. So angle F starts between here and here. 0, 10, 20, 30, what's it look like? 35, I'd say. There's a 36. I'll look at that later when I view the video. Can't really tell. And then the other angle G, you could do it a couple ways. You could start at the 90 and count 10, 20, 30, 40, 50 and the difference, 54 or 55 depending on where it is. Or you could rotate like this and get your 0 on that line and measure from here to here and get your 55 that way. Because these two angles are on the other side of a 90 and the line at the bottom is straight, these two angles, say 55 and 35, they had to give you 90. And that's another term you must lock into your memory bank. When two angles that are side by side or adjacent, and they share a common side in the middle, and they had to give you 90, they are called complementary angles. Think about the word complement starting with the letter C. C's make corners, and corners are 90s. Back up at number 2, we had two angles side by side that were adjacent. They had to give you 180, but they were supplementary. Think S, straight. 180, S, supplementary, corner, complementary, makes a 90.